Hello students, today we will start to learn about the afterburner. This is the first section of our study on the afterburner. In this section, students need to start from the structure and learn the relevant knowledge of the afterburner to facilitate the subsequent study of its basic components. Regarding the afterburner, we have already learned about the combustion chamber part before, so let us first define what afterburner is. Generally speaking, we call the engine afterburner when the engine continues to increase thrust after reaching the maximum state. Why do we use engine afterburner? Because engine afterburner is the best way to increase thrust in a short period of time. The thrust calculation formula is F equals Qm mass flow multiplied by exhaust velocity V5 minus intake velocity V0. There is also a calculation formula for exhaust velocity V5, but this is not the focus of our study in this class, so I will not go into details. There are usually two afterburning methods, namely liquid injection after burning and afterburning after burning. At present, the most widely used afterburning method is to install an afterburner between the turbine and the tail nozzle for afterburning. In previous supersonic aircraft, the afterburner was an indispensable basic component of the engine. Therefore, the role of the afterburner is to increase thrust. The specific process is to spray fuel into the gas flow after the turbine while maintaining the maximum engine speed and the gas temperature before the turbine unchanged, and use the remaining oxygen in the gas to burn again in a double-ducted engine. Fresh air can also be introduced from the outer duct to further increase the temperature of the gas, increase the jet speed, and thus increase thrust. One thing to note is that, as shown in the figure, all engines with afterburners must have tail nozzles with adjustable areas. The afterburner is composed of diffuser, flame stabilizer, oil transfer ring, and fuel nozzle ignition device, afterburner, shell, etc. In the double-ducted engine, it also includes a mixer. Next, let's look at the pictures to strengthen our impression. The left picture is the diffuser, which is mainly used to reduce the airflow speed entering the afterburner to create conditions for stable combustion. The right picture is the afterburner shell, which provides physical protection, sound insulation, heat insulation, sealing, etc. Both of these pictures are flame stabilizers. The function of a flame stabilizer is to create turbulence in the airflow, form a recirculation zone, accelerate the formation of the mixture, and strengthen the combustion process, stabilize the flame, and improve the degree of complete combustion. The left picture is a V-groove radial flame stabilizer, and the right picture is a dune vortex flame stabilizer. In these two pictures, the left side is the oil transfer circle, and the right side is the fuel nozzle, which are used to supply fuel. The picture on the left is the igniter, and the picture on the right is the pre-ignition. Students, in this class, we learned about the afterburner structure. In the next class, we will study the specific components of the structure. Students must master today's knowledge in a timely manner and be able to apply it to other situations.